Hello, this is Jeremy Porritt. This is hopefully my third and final attempt of doing this video. This is for game physics. My student ID is 101367286. Did this on my iPad, recording it on here. Let's get started. So we'll go back to the first page. This is my formula sheet. Didn't use all these formulas, but yeah, this is what I'm going to be showing off that I used. So for the first question, it's the first test launch. We're given the mass, which we don't use, but we're given the velocity, the angle, and the gravity. Using that, we can draw this triangle here, which we make the hypotenuse, the velocity, and here's the angle here. And using SOHCAHTOA, these formulas here, we're able to find the x with cos theta a over h by rearranging it. So instead we would just do, we're trying to find a, so we just do hypotenuse times cos theta, and we do hypotenuse times sine theta to find the y, which is done here, and the answer for a is here. So it's 112.76 and 41.04. I use 2 decimal points because in previous physics assignments I've done in the past, we've only gone to 2 decimal points, and it is not stated in the rubric how many we have to use. Moving on to B, we have these two formulas. It's just a mix of the third kinematic equation, which is, actually it's the fourth one, it's this one here. And I have the version of it that's modified, so the y stays the same as the original kinematic equation, but the x doesn't have acceleration because the acceleration is 0 on x. Therefore, we have the x formula here, so subbing in the x distance, or the x height, which is there, times t, and the y version, subbing in for y, or subbing in what we need here with the height. And y velocity. And so with that, we can use the quadratic equation to get t, because we want t to find x, because we want to find the distance for part C, which is where will the package touch the ground. So using that, we have the quadratic equation. So to sub for 0 for y, because y is the ground. And so over here, we just have that. And then we do the quadratic equation. You can see I define A, B, and C to sub in for the quadratic equation there, which gives us the positive result, which is a negative. So because it's plus or minus for the quadratic equation. So negative 10, which we can't use because that's behind. So the time taken is 35.77. Now subbing that in for x, we get 112.76 and 35.77. Multiply those together, and we get 4,033.43. When the package hits the ground. D, I go through the explanation here, but 70 degrees will result in the same distance as 20 degrees, as the x and y will just be flipped, knowing that 45 is the midpoint of degrees, and that will result in the maximum distance we can create. It will allow us to know that when it's 70 degrees, that's just 20 away from 90, and 20 degrees is just 20 away from 0, and they both have the same distance to 45. Therefore, it will be the same distance for both of them. And, I mean, knowing that the x will be... Knowing that the x will be 41.04 and the y will be 112.76, we'll be able to understand that it will be the same distance. Going on to part 2, a lot less writing here. We are calculating for not for 1600, but for, oops, we'll just fix that. We're calculating for 160, and, the distance will be this one, 100. And so, knowing that, we have the max range formula here. I'm messing up my stuff there. Max range formula there, which is range initial velocity squared sine to theta over gravity. So just plugging that in, I'm trying to see if this works. So I just kind of rearrange it and see what it gives me, which it gave me 0.32 degrees, which I thought might be wrong, but subbing it back in gives me the same answer, and then checking other distances worked as well. So I rearranged the equation, and it gave me inverse of sine to the inverse of sine of the distance times 1.6 over 14,400 over 2 equals theta. And knowing that, we can move on to part 3, which figuring out the distance. So using a calculator, I just put in the different distances. I'll explain for 1,000 meters. So for 1,000 meters, I got 3.19 degrees. And knowing that we can get the other angle, which it will just be 90 minus 86.81 degrees, because we know that 45 is the halfway point. And for this, you're supposed to go up to 10,000 on the graph. Seeing that 9,000 has 45 degrees for both of them, that means it's the maximum distance it can travel. So it will not be able to travel to 10,000, as y it's set to not applicable. So yeah, that's pretty much it. I just filled in the rest for that, just plugging in the different distances to the formula. And then for the bottom angles, I just plugged in the other, I just plugged in this angle for 90 minus this angle gives me 69.09. And yeah, so that's everything. Thank you for watching. Bye.